Hello, this video is part 1 on inverse functions. In part 2 of this section, we will be doing a Python program that will do exactly what we are doing here in this video. So on inverse functions, what we will be mainly focusing on today are finding the inverse of a function and also verifying if two functions are inverses. We also have a last problem. This is finding the inverse, just like the first problem we are doing. So what I have here is a OneNote document about steps in finding the inverse of a function. I have 4 steps. So the first step for us is to switch from f of x to y. So we'll be given a function f of x equals something in terms of x, like 3x squared plus 5x plus 9 or something like that. So our first step would be switching from f of x to y. So we would say y equals blah blah. Okay, and then we switch x and y. We are going to switch x and y. So you have y equals something, y is on the left side, and the x terms are all on the right side. We are going to set x on the left side equals some terms of y on the right side. And then we're going to solve the equation for y. And lastly, we're going to switch from y to f inverse of x. Those are the first steps that we will be following today. All right, so let's look at the first example here. It says find the inverse of f of x equals x minus 3 over 5. So I'm going to make this bigger, and let's go ahead and solve that. So we're going to follow all the steps that we had above in this problem. So our first step was to switch from f of x to y. So we're going to say y equals x minus 3 over 5. Our next step, we said, is switch x and y. So x equals y minus 3 over 5. That's our next step. And then the following step is solving the equation for y. So this is solved for x right now. So when we do that, we have 5x equals y minus 3, and then plus 3 on both sides. This is a bit too thick there. Okay, so plus 3 on both sides of the equation. We get that 5x plus 3 equals y. So our last step here, I want to put the y on the left side again. That's the traditional way of doing it. So this is y equal 5x plus 3. And then our last step above, we said change from y to f inverse. So this means that f inverse of x equals 5x plus 3. And that's how we solve an inverse function. It'll always be a linear function because a quadratic function doesn't have an inverse, because it fails the vertical line test. If we have a quadratic function, we want to take the inverse of that. We need to account for only the positive values or the negative values of that function. Say f of x is x squared. We would only take the positive version, so plus x squared. So that would take the positive inputs, and the inverse of that would be square root of x, where x is positive. So that's why we don't focus on inverse functions on quadratics so much. So this section will all be on linear functions, inverse functions of linear functions. All right, so that's how we find inverses. So now we're going to verify if two functions are inverses. So the way to do this is they are inverses. Say function 1 is called f and the function 2 is called g. So those are inverses if and only if both of their compositions are the identity function. So that is f composite g of x equals x and g composite f of x equals x. This is what this symbol means here. This is composition of functions, composite. So in this video, we're not gonna. The emphasis of this video is not is not the composition of functions. We're under the assumption that you already know composition of functions. If you don't, you can maybe find another video or study that first. But we are going to be doing composition of functions here, so you can learn it that way if you're unfamiliar with it or you're rusty on it or something like that. So with that said, let's look at example 2, and we're asked to verify if f of x equals 2x plus 8 and g of x equals 1/2 x minus 4 are inverses. So I need to focus on this. I need to look at f composite g of x and g composite f of x, and I need to get the identity function x. So let's compute f composite g of x here. So f g of x. This is notationally another way of writing this notation here. So we're looking at f of g of x, and this is equal to f of, well, g of x is 1/2 x minus 4. So think of it as a machine. We're now inputting g, which is 1/2 x minus 4, into the f machine or f function. So we're evaluating g in f. So this equals anywhere I see x in the f function, I will input this entire chunk here, that entire chunk which is g. So this equals 2 times 1/2 x minus 4 plus 8. So don't forget the last term. We're only plugging in for x. We're plugging in g for x. Okay, so let's distribute this 2 here. 2 here in the front, and then this 2 in the denominator cancel each other. So I'm left with x. And then when I distribute the 2 into the -4, I get -8 plus 8. And this equals x. So this does equal the identity function. So we have a check mark there. Let's come down and compute g composite f of x. So g of f of x, this equals g of, we said f of x is 2x plus 8 up here. So g of 2x plus 8. So this equals what? Equals, anywhere I see x, I will put x in the g function, I will put this 2x plus 8 there. So this equals 1/2 times 2x plus 8, and then we had -4. I'm gonna actually erase this, and just so that we're aware, 2x plus 8, and then likewise erase this and put g in there, which is 1/2 x minus 4, just so that we're not confused on what's going on. This is the g function inputted into x. Okay. So when we do this, let's do some math here and distribute and combine like terms and whatnot. So the 2x and the 1/2 become x, and then when I distribute this 1/2 into the 8, I get +4, and then -4, this equals x. All right, so we have a check mark there. So that means f composite g of x equals x, and g composite f of x equals x. So therefore, we can come here, down here, therefore f and, if we can, f and g are inverses, because we computed the composition function of both y's, and we got that the identity function. So that's why. All right, so that's how we do that problem. Lastly, I have another problem to find the inverse of. Well, actually, I want to make another point about checking for inverses, checking if two functions are inverses. If you compute f of x and you didn't get the identity function, f composite g of x, and you didn't get x, say if this was, I don't know, x plus 3 or something like that, that means we didn't get the identity function, and you can just stop right there. You don't have to compute g to check for inverses. We can right then just say these two functions are not inverses because f composite g of x didn't give us the identity function x. Likewise for g, if you computed f and you got the identity function and you computed g, you didn't get the identity function, then this means that the functions are not inverses. All right, example 3, we are asked to find the inverse of f equals 9/5 c plus 32. So this is one application of inverses in real life. This is converting temperature, Fahrenheit and Celsius, and inverses are also very useful for other units in physics. Say if you want to convert from meters to feet or miles to kilometers and so on. Those are inverse functions. We use inverse functions to compute those. Anyway, let's find the inverse of this function f equals 9/5 c plus 32. I'm going to use the steps above that we solved for the first problem. So we're going to follow these 4 steps into the example we have down here. So let's come down here. The first step is already done for us. We don't have to write f as a f inverse, or yeah, we don't have to convert from f inverse of, or f of x to y or anything like that. So the first step for me is to write c equals 9/5 f plus 32. And here we're going to solve for f. So when we solve for f, we get the f inverse, and then we're going to have to switch back f and c, and that will give us a temperature in Celsius. So let's do that. So if I move the 32 over to the left side, I get c minus 32 equals 9/5 f. So now I can multiply both sides by 5. Multiply by 5 on both sides. So this gives us what? The 5's cancel here. So I get 5 times c minus 32 equals 9f. And my last step is to divide by 9 on both sides. Divided by 9. So one of our last answers here is f equals 5 over 9 c minus 32. But this f is f inverse, and we do have to switch back. So this is implying f inverse equals 5 over 9, and then this is f minus 32. So this implies that c equals 5 over 9 f minus 32. So that's how we solve inverse functions and how we check for inverses in math. So in the second part of this video, we'll create a Python program that will compute, that will do everything that we did here through a Python program. That's it for today. Thanks for watching.